Alright, so in this problem, I'm going to be proving that 0 divided by 0 is equal to 2. So first off, I'm going to simply start with 0 divided by 0. And now 0, this is the same thing as 1 minus 1. So now I have 1 minus 1 over 1 minus 1. And 1 minus 1, that's the same thing as 10 minus 10. All of this is equal to 0. 1 minus 1 is 0, 10 minus 10 is 0. And 10 minus 10, this is the same thing as 100 minus 100. So I have 100 minus 100 over 100 minus 100. Now 100, this is the same thing as 10 squared. So 100 minus 100 over 100 minus 100, this is the same thing as 10 squared minus 10 squared over, instead of writing this as 10 squared minus 10 squared again and for the denominator, I'm instead going to write this as 10 times 10, which is the same thing as 10 squared. However, now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So 10 squared minus 10 squared, let me write that right here real quick, 10 squared minus 10 squared over 10 times 10 minus 10 times 10. This is going to equal 10 plus 10 times 10 minus 10. And now from the denominator, if I factor out 10, if I factor out 10 from the denominator, I get 10 times, from here, all that's going to be left going to be is 10 minus, from here, 10. And now, I'm simply going to cancel out these two 10 minus 10s. So now I'm going to be left with 10 plus 10 over 10. Now, 10 plus 10, that's the same thing as 20. So I have 20 over 10, and 20 divided by 10 is simply 2. So, as you can see, I just proved that 0 divided by 0 is equal to 2. Now, there actually is a mistake here because obviously 0 divided by 0 is not equal to 2, and the mistake is right here, where I canceled out 10 minus 2 over 10 minus 2. Well, remember, 10 minus 2 is 0. So this is essentially dividing 0 with 0, and remember, 0 divided by 0 is not 1. So that's why I cannot cancel these two out. So that's where the error of this was. Alright, so in this problem, I have 1 over m is equal to 27 to the power of m. So to solve this, I'm going to first start by taking the power of 1 over m on both sides. So now I have 1 over m to the power of 1 over m is equal to 27 to the power of m to the power of 1 over m. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 27 to the power of m to the power of 1 over m, that's the same thing as 27 to the power of m times 1 over m. And m times 1 over m, that's, these two cancel out, so that's just going to be left with 27. So now I have 1 over m to the power of 1 over m is equal to 27. Now 27, this is the same thing as 3 to the power of 3. So now I have 1 over m to the power of 1 over m is equal to 3 to the power of 3. And if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, 1 over m, that's equal to 3. So now to solve this, I'm simply going to multiply both sides by m. These two cancel out, and I'm left with 1 is equal to 3m. Now I'm going to go ahead and divide both sides by 3. So then these two cancel out, and I have 1 over 3 is equal to m. Now, to check, first start with 1 over m is equal to 27 to the power of m. And we know that m is 1 over 3. So now I have 1 over 3 is equal to 27 to the power of 1 over 3. Now, 1 divided by 1 over 3, that's the same thing as 1 over 1 divided by 1 over 3, which is the same thing as 1 over 1 times 3 over 1, which is equal to 3. So now I have 3 is equal to 27 to the power of 1/3. Well, 27 to the power of 1/3, that's the same thing as the cube root of 27, and the cube root of 27 is 3. So I have 3 is equal to 3, and this is right, so my solution is right. Alright, so in this problem, I have x to the power of x is equal to x to the power of 2. So to solve this, what I'm first going to do is I am going to take the natural log on both sides. Or sorry, actually before that, what I'm going to do is I'm going to divide both sides by x to the power of 2. So x to the power of 2 divided by x to the power of 2, that's 1. So now I have x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So x to the power of x over x to the power of 2, that's equal to x to the power of x minus 2, which is equal to 1. Now, if I take the natural log, or ln, on both sides, I get ln x to the power of x minus 2 is equal to ln 1. And if I have something in the form ln a to the power of b, I can actually move this exponent b to the front. So this can equal b times ln a. In this case, ln x to the power of x minus 2, I can move x minus 2 to the front. So this can equal x minus 2 times ln x, which is equal to ln 1, which, if you guys already know, is 0. Now, if I distribute the ln x, well, x times ln x, that's x times ln x, negative 2 times ln x is negative 2 ln x. Now I have this is equal to 0. Now from here, if I factor out ln x, actually, there is no need to factor there is no need to distribute ln x out. That was my bad. Instead, I'm going to make this into two equations. I have x minus 2 is equal to 0, and I have ln x is equal to 0. So x minus 2 equals 0. This is pretty simple. All I have to do is add 2 on both sides, and I get x is equal to 2. So this is already one solution of x. Now for ln x equals 0, I'm going to take e to the power of both ln on both sides, e to the power of both sides, and e to the power of 0, that's 1. E to the power of ln x, e and ln x cancel out, e and ln cancel out, so I'm left with x, so I get x is equal to 1. So my two solutions are x is equal to 2 and x is equal to 1. Alright, so in this problem I have 9 to the power of 900 minus 9 to the power of 901. So, for my solution, I'm going to first start by rewriting my original problem here. So I rewrite 9 to the power of 900 minus 9 to the power of 901. And now this is the same thing as, can rewrite 901 as 900 plus 1. So this is the same thing as 9 to the power of 900 minus 9 to the power of 900 plus 1. Now, there is an important exponential property that you guys should know. So if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, we have 9 to the power of 900 plus 1, and using this property, we can rewrite it as 9 to the power of 900 times 9 to the power of 900 and, 9 to the power of 1. Now from here, notice how we have two terms here. Our first term is 9 to the power of 900, and our second term is 9 to the power of 900 times 9 to the power of 1. So because both of our terms have 9 to the power of 900 in them, we can factor that out. So we can factor our 9 to the power of 900, and we get 9 to the power of 900 times, 9 to the power of 900 divided by 9 to the power of 900 is 1, minus 9 to the power of 900 times 9 to the power of 1 divided by 9 to the power of 900 is simply just 9 to the power of 1. So I get 9 to the power of 900 times 1 minus 9 to the power of 1. And 9 to the power of 1 is the same thing as 9, so I get 9 to the power of 900 times 1 minus 9. Now from here, I'm going to simplify what's in my parentheses here. 1 minus 9 is negative 8, so I have 9 to the power of 900 times negative 8. And I can rewrite negative 8 as 8 times negative 1. And now I'm going to multiply negative 1 with 9 to the power of 900. So I get negative 9 to the power of 900 times 8. Now from here, I can rewrite my 9 here as 3 squared. So I get 3 squared to the power of 900 times 8. And now 8, I can rewrite as 2 to the power of 3. So I have negative 3 squared to the power of 900 times 2 to the power of 3. And now remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this can equal negative 3 to the power of 2 times 900. And now I have this times 2 to the power of 3. And if you guys already didn't know, 2 times 900 is 1800. So I have negative 3 to the power of 1800 times 2 to the power of 3. So this is our answer in its most simplified form. We can't, if you want, you can try putting in 3 to the power of 1800, but that number is way too big for any calculator to actually be able to output. So this is the simplest form that we can put our answer in. So that is our answer to 9 to the power of 900 minus 9 to the power of 901, and see how much big of a difference it is.